Thank you so much, Veda. I thought my volume was coming. I will just repeat this question. Thank you for highlighting. I hope I am audible now. Please give me a thumbs up once I'm audible. Thank you. Okay. So it says consider a dice with property that the probability of face with n dots showing up is proportional to n, right? So I said that a dice can have 6 faces, right? And when we talk about each phase, so the first phase only has 1 dot, the second phase has 2 dots, the third phase has 3 dots, the fourth phase has 4 dots, and so on and so forth. So I am saying that because this is proportionate to number of dots, so let this be 1 into k, the probability of the first side. Let this be 2 into k. Let this be 3 into k. Let this be 4 into k. Let this be 5 into k. And let this be 6 into k. Now we know that the sum of the probability is going to be 1. So this probability plus this probability plus this plus this plus this plus this, it should be 1. So if I just go ahead and add all of these together, I will get 21k is equal to 1. And from here, I will get k is equal to 1 by 21. Now the question is asking what is the probability of the face showing 4 dots. So this was 4k. So I will go ahead and multiply this with 4. So 4k will become 4 by 21. And that would be the answer to this question, right? So let's take the next question. Try to read the question. Try to do it yourself first. It says, let x be a random variable with probability distribution function given to you. So it says f of x is equal to 0.2 when mod x is less than 1. And this says f of x is equal to 0.1 when mod x is between 1 and 4. Try to answer this question yourself first. So this is going ahead and asking and 0 otherwise, right? So this is asking you that what will be the probability when your x is greater than 0.5 but less than 5. Try to do this question yourself first. Then I will go ahead and tell you how you can do this question. Answer it in the chat window. You are given a probability function. It says mod x when it is less than 1, the probability function is given as 0.2. When it is between 1 to 4, it is given to you as 0.1. And it is asking you what will be the probability when it will be between 0.5 to 5. Okay, let's try to do this question together. So what we can do, we can just break this interval of 0.5 and 5. And what I can do now, I can just plug a 1 here, right? And then this is going to be a 4 here. And then this is going to be between 4 to 5. I have just broken the entire interval in many parts. Now, what you can go ahead and you can do is that you can open this up. So this means that this is probability is going to be 0.2 whenever your x is between -1 to 1. Whenever your x is between -1 to 1, the probability is going to be 0.2 when x is between -1 to 1. And this tells you that when x is between 1 to 4, your probability is going to be 0.1, right? And it says that it is going to be 0. So this gives you mod x is between 1 to 4. So when I just go ahead and I open mod x between 1 to 4, it means that either x is between 1 to 4 or x is between -4 to -1. Right? Because this says mod x, right? So in that space, we understand that this is going to be 0.1, right? And now anything before or after that, it says it is 0 otherwise, which means between 4 to 5, it has not been given to me and it is going to be 0 otherwise. Now what I have to go ahead and I have to do is that I need to go ahead and I need to evaluate this part. I need to evaluate this part. What will happen when my probability is between 0.5 and it is between 0.5 to 5. This is what I need to go ahead and I need to evaluate, right? So what we can go ahead and simply do is add these probabilities together. So here I'm given 0.2, right? Between 0.5 to this, I'm given 0.2, right? And here I am given that this stands for 0.1. And here I am given that this stands for 0. So this is how you need to first go ahead and break this probability. Am I clear? This is a very, very important question from exam point of view. Beta, बहुत important है. Such questions can be asked in exam. Right? So what we can go ahead and do, therefore, we can just add these probabilities together. So I will say this is the probability that X is between 0.5 to 1, right? Plus, this is the probability that X is between 1 to 4, plus this is the probability that X is between 4 to 5. And once you have done this, you can just put these values, add them together and get the answer to this question. The next question, it says which of these is not true in terms of probability distribution of any continuous random variable. So you're given that between 2 points A and B, the area under the curve would be represented by that of X is equal to A. So try to understand this thing. It says that you have a continuous random variable. So suppose I take any continuous random variable. Suppose this is my probability density function. I can also take a uniform probability density function and it can be represented by this. It has to be continuous in nature. Now I go ahead and I take 2 points. So this point represents point B. This represents A. It says it is continuous between A and B. So I have just made this continuous. Now it says area present under the curve would be represented by the probability that X is A. This is incorrect. Absolutely incorrect statement. Why is this incorrect? Because we know, beta, that whenever we have a continuous variable, then probability at a point is 0. Probability at any point, whether I say point A, point B, point C, probability at a point is 0. So whenever we talk about the probability of a continuous variable at a point, it should have been 0. And if I want to go ahead and I want to give CDF, right? Or I want to define its PDF also. So for a continuous variable, we know that its probability density function will be given by 1 upon B minus A, and CDF will be given by X minus A upon B minus A, right? So I can find the area under the curve between A and B, but I cannot go ahead and define by X equal to A. So that is an incorrect statement. So it is saying which of the following is not true. So A itself is not true. Look into the other statements. Under the curve, the total area present will be equal to 1. This is correct. Because the area under the curve represents the total probability. And the probability, total probability means it has to be 1. So this is the correct statement. This says we can find the range of the random variable on the x-axis. This is also correct. Whenever we talk about where my random variable x is lying, it is lying between A to B in this case. So exactly where my random variable will be lying, what is the range of my random variable, I can know it through the x-axis. So this is also correct. And last statement says the probability density function is represented by the vertical coordinate. Yes, this is 1 upon B minus A. So the vertical coordinate will represent the probability density function. And therefore, we can go ahead and say that this is also a correct statement. So D is also correct. Let's go to the next question. It says, which of these does not refer to a normal distribution character? It is a type of bell-shaped distribution. This is correct. It represents a bell-shaped distribution. Look into the next question. The mean, median, mode are equal to each other. This is also correct. It is symmetric around mean, median, and mode. This is a correct statement. The mean is always 0. This is incorrect. This is true for a standard normal variable. So when x is normally distributed with mean x bar and standard deviation sigma, then x minus x bar, excuse me, then x minus x bar by sigma, this is a standard normal variable and this will have mean 0. But I cannot say that x will have mean 0. That is an incorrect statement. So statement C is incorrect. Then D says it is symmetrical type of distribution. This is also correct. So the correct answer to this question will be C. Okay. Come to the next question. It says for the exponential distribution that has a parameter lambda, which of these statements would not stand true? Okay. Since the standard deviation and mean are equal, distribution would have 2 parameters. This itself is incorrect, beta. The distribution only has 1 parameter lambda. It doesn't have 2 parameters. Its mean and standard deviation are equal. So if mean and standard deviation are equal to each other, there is just 1 parameter, that is lambda, right? So statement A itself is incorrect. This says the area that is present under the curve is 1. This is true for all distributions, beta, that the sum of probability must be 1. And when I talk about continuous distribution, that this must be 1. When I integrate it from minus infinity to infinity, the area under the curve must be 1. So this is the correct statement. The standard deviation happens to be 1 by lambda, correct. Mean happens to be 1 by lambda, correct. Right? So statement number A is incorrect, that the parameter, there are 2 parameters. There is just 1 parameter lambda. Okay. Come to the next question. It says which of these distribution is the best for measuring total time elapsed between the time of arrival of vehicles at a gas station. Now try to understand that whenever we talk about the time elapsed, we are talking about a continuous variable, first of all. So it cannot be binomial, right? And it cannot be Poisson. Secondly, whenever we talk about things like this, कि कितना time चला गया है, कितना growth rate है, we go for exponential or Poisson. So in this case, it cannot be Poisson because we are talking about time. It is a continuous variable. So therefore, the right answer to this question can be exponential. So exponential is the correct answer. Okay. Come to the next question. It says, assume that a test has 30 multiple choice questions and every question has 4 different choices. Assume that a student who hasn't studied anything for this test decides to randomly answer all these questions by guessing their answer. In this case, which of the following probability distribution we would like to calculate the actual chance of student getting minimum of 20 answers? So try to understand. In such questions, we are saying what is the probability that he gets more than 20 correctly. But when we talk about these kind of questions, there are only 2 things. Either the answer is correct or the answer is incorrect. When the answer is correct, that is success with probability 1 by 4 because only 1 answer out of 4 can be correct. When the answer is incorrect, the probability will be 3 by 4. Right? So for each answer, he is going to either answer it correctly with probability 1 by 4 or answer it incorrectly with probability 3 by 4. This is for each question. And there are 30 questions. So out of 30, we want him to go ahead and answer 20. Out of 30, we want him to answer 20 correctly into probability of answering it correctly and probability of answering it incorrectly. And it says at least 20. So 20 or more than 20, to 30C 21 के साथ, 30C 22 के साथ, I will repeat the process. But try to understand that I am using a binomial distribution. So answer will be binomial. Okay. Now come to the next question. It says the wait time in front of an ATM machine is very popular, in a very popular shopping mall, is uniformly distributed between 1 to 5 minutes. So we are given that it is between 1 to 5 minutes and it is uniformly distributed. Okay. What would be the probability? So what is going to be this beta? Probability यहाँ पे क्या आ जाएगा? 1 upon B minus A. That means 1 upon 5 minus 1. That means 1 by 4. Right? Now, we need what is the probability of waiting between 2 to 4 minutes? That means I want to find out this. Here I have 2 and here I have 4. Right? I want to find out this. What is the probability of waiting between 2 to 4 minutes? This is what I need to go ahead and I need to find out. Right? So what is going to be this area beta? So the length, right? That is 1 by 4. And the breadth, that is 2. So my area will be 1 by 4 into 2, 1 by 2, 0.50. Right? So the answer to this question will be 0.50. 0.50. Right? Okay. This value beta is coming from 1 upon B minus A, 1 upon 5 minus 1, 1 by 4. Okay? The x-axis, y-axis, vertical coordinate. Okay, read the next question. It says, in an examination paper, there are 150 MCQs carrying 1 marks each. Every question has 4 choices and every incorrect answer fetches a negative of 0.25 marks. If 1,000 students choose random answers with uniform probability, then what would be the total number of expected marks that every student will obtain? Let us try to solve this question. So in this question, they are going ahead and they are telling us that I'm just going to open the calculator also for this. So we have 150 questions, each of 1 marks. So what we can go ahead and do in this case is 150 questions. For each question, I am just marking the answer randomly, beta. So since I am marking the answer randomly for each question, either the answer will be correct or incorrect. Right? If it is correct, then I will get 1 marks. If it is incorrect, then I will go ahead and get negative 0.5. So minus 1 by 4 marks. So there can only be 1 correct answer out of the 4 options. So the probability of it being correct is 1 by 4. And the probability of this being incorrect will be 3 by 4. So what will be my expected marks per question? My expected marks per question will be 1 by 4 into 1 plus minus 1 by 4 into 3 by 4. So this is going to be 1 by 4, 1 minus 3 by 4, 1 by 4 into 1 by 4, 1 by 16. These are going to be my expected marks, 1 by 16. Now, it goes ahead and it says that there are 150 questions. Okay, so I will just go ahead and get the expected marks in 150 questions, right? So 1 divided by 16 into 150, this is going to give me 9.375. And now this goes ahead and it tells me that there are 1,000 students. So I will just go ahead and multiply it with 1,000. So this will give me 9,375 marks. So these are going to be my expected marks in this paper. 9,375 would be my expected marks. I hope this question is clear to you. So the correct answer to this question will be D, 9,375. Okay. Okay, beta. So now this question is your homework question. try to do this question yourself. It says that the security system of an IT company consists of 10 computers and exactly 4 of these are working. So 10 may say out of 10 computers, 4 are working and 6 are not working. To check if a system is actually functional, the officials pick 4 computers at random. So out of 10, I am picking up 4 computers at random and inspect them without replacement. So I pick up the first computer, I keep it aside. I pick up the second computer, I keep it aside. So it is without replacement. The system will be considered functional if at least 3 of the 4 inspected computers are working. So try to understand this thing. I have 10 computers. Out of these, I am choosing 4 computers. And I need at least 3 of them to be working. This is what it is saying, right? If at least 3 of the 4 computers are working, if P is the probability that this system would be considered functional, then 100 times P is, right? So I hope that you will be able to go ahead and do this question on your own. I'm giving you this as a homework question. The answer should come out as 11.90. It's a pretty simple question. You will expect this kind of questions in your IIT Delhi and Kanpur paper, right? Just try to do this and post your answer. I will try to come up with 1 or 2 more marathons tomorrow and day after for other subjects also. But from the side of statistics, please expect questions on probability and different kind of distributions. These are the kind of questions that you can go ahead and expect in your end exam. Okay, beta. Thank you.